Today we'll do some last week. Sorry, some last week.
I'm not sure how I did it.
Okay. What are we doing in general?
Post-optimality.
Yes, what's that mean, post-optimality?
But you did it after you've done it.
What you do after you've done it? Yes. So which bits were we looking at? We were looking at several things that can change after you've solved your linear programming problem to optimality, and then something changes. Which bit have we done? Pardon? Did you say anything? Right-hand side change. Adding a new constraint, yeah, that's the other word. Anything else? Adding a new decision variable, exactly. Anything else? So what's left to do? Changing the objective coefficients, that's one of the main things. So this is what we're going to do today, changing the coefficients in the objective function. And then there's not much left, so that you can start changing some coefficients in the constraints, but it gets slightly messy. So we won't spend too much time on that. But then next week, what we'll look at is kind of sensitivity analysis. So more or less, we'll be looking at how much the various parameters, the various things in the formulation can change, the various coefficients on the right-hand side can change without influencing which basis is optimal. Okay, so how much can you change the values so that the basis that was optimal still remains optimal? You can change the optimal solution, but you don't have to pivot to get the new optimal solution. So this is the plan for next week. But this week, first we'll look at the homework problem, and then afterwards we'll do changing the objective function. So let's start with this. And how does this go? Question A says that the optimal basis is whatever it gives it to you, S1, X1. And you've got the inverse matrix there. So what do you do if you want to get this tableau? Or what have you done? Because it was your homework problem. Okay, so one thing, if you didn't want to do any of the things that we've been learning, then you realize that it's just one pivot step away from the initial tableau, where you replace S2 with X1, and you can start with the original tableau and do one pivot. If you wanted to do it, however, without pivoting, what would you do? Wake up, please. Okay, it all rests on what goes on there, what we've done 20 times already. Namely, this. Okay. Now, you don't remember the formulas? Well, you probably should. And even if you don't remember the formulas, you should remember what goes on. Somehow algorithmically. Okay, so what goes on is that if you know this bit, that's crucial. Okay, that's the inverse matrix. You can get it somehow as the inverse of a certain matrix, but now it's given to you, so you don't have to calculate the inverse matrix. So with that MB inverse, you can easily do the rest of the tableau here, ignoring the objective row for the moment. And where you do it is you look at if you want the val column, you look at 10 and 15, the right-hand side's over here, and you take 10 times this column, 15 times the second column, add them together. Okay? So that gives you 2.5, 5 over 2, and 7.5. Now, if you want the x1 column, you look at the coefficients of x1, so that's 1 and 2. So you take 1 times this column, 2 times this column, add them together. What you get is 0 and 1. Is it clear? Okay, I'll assume that it's clear because there are no questions. Okay, x2, what are the coefficients? So what do you get? 0 and 2. x3, what are the coefficients? 2 and 3. So what do you get? 2 times 1 minus 3 halves. That's 1 half. Is that right? I hope so. And 2 and 3, 3 halves. Said the same I got last year. Yes, good. Now for the objective, look at this. It's some C dash B times whatever is above. Times C dash B times whatever is above. Times C dash B times whatever is above. We'll take away C. Okay, so the pattern is almost the same everywhere. The C dash B, that's the coefficients in the objective function of the basic variables. So what's the coefficient in the objective function of the S1 variable? 0, because it's not in the objective at all. And x1? 3. Yes. So here you get 3 times 7.5. These are a bit more complicated. Here you get 0 because it's 3 times 0. Here you have get 3 over 2. Here you get 3 times 1. Take away 3. So that's 0. Here you get 3 times 2. Take away 5. So that's 1. And here you get 9 halves. Take away 2. So that's 1 half. Okay. Is that clear how I got these numbers, or do you have any questions? Does anything need to be clarified? Okay.
Why is 9.5 minus 2.5?
Yeah, it's 9
Is it not?
over 2 minus 2. Shouldn't it be 5 over 2?
9 halves minus 2 is 9. It's 5 over 2. Yes, you're right. Thank you for spotting this. Any other errors? I could always say that it was intentional to check that, but it wasn't. Okay, so the optimal solution would be x1, x2, and x3, 0, and the objective z is 22.5. Okay. Now, something we did last week, add a new constraint. So what happens if we add a new constraint? Say the numbers. 2.5, 0, 0, okay. So this one is also a copy, isn't that? 1, 2, 3 over 2, 0, 1.5. Okay, S3.
6, 3, 1, 2.
Why?
Copying the new constraint.
Exactly, that's the new constraint. Objective. Any change? No. Why did it say restore the simplex property?
Let's do another one of those.
Because this is not a simplex tableau. It looks like a simplex tableau, but it's not, because the basic variables don't have this 1, 1 rest zeros in the column. Okay? 3 that shouldn't be there. Must be something else. Is there anything else that's wrong? No, that's the only thing. Yeah, but, anyway, that shouldn't be there. So this should be 0. Once you get a 0, simple row reduction, 3 times this row away from that row, get 0 there. So, wow. So if you do that, the S3 row is going to be what? Well, a 0 there. We know that. Is minus 16.5? Minus 5. This is the one I can't do. 9 over 2, take away 2. It's 5 over 2. 0. Like this. Any errors spotted there? The rest of the tableau is the same as above. I'm not writing it. It would be a waste of time. So now in here, if we have a tableau where the S3 row is like this and the rest of the tableau is like that, what do we do? Dual pivoting. Why do we do dual pivoting? Negative value here.
Objective.
This one? Okay, exactly. So how does one choose the dual pivot? Pick something negative in the valve here, rather than this one. So that's your pivot row. Now for the column,
The negative values are going to be objective over
this one, or that one, or that one,
the smallest one.
and the smallest one.
When you do the ratios.
When you do the ratios, yes. Which ratios?
Objective.
1 divided by 5. Okay, that's 1/5. This divided by that, that's 1 in absolute value. And this divided by that, that's 1 as well. So the least one is the 1/5. And ignoring, well, not ignoring, but you have to take the negative. Yeah. It's closest to 0. Okay, it's this one. Aha. So that's the pivot element. So what does that mean? That means that S3 has gone out of the basis. You get X2 here, S1, X1. So you have to divide everything by 5. Apparently what you get is 3.3. And 0, and 1. And 1/2, and 0, and 3/10, and minus 1/5. Does that look like the right thing? Okay, so and then I won't bore you with the rest, but it should be 2.5, 0, 0, 1/2, 1, minus 1/5, 0, I hope, 1, 0, 1/2, 0, minus 1/10, 2/5, and 19.2, 0, 0, 2, 0, I think that's 6/5, and 1/5. Well, you probably can't check this as quickly as this. There you go. That's just a normal pivot thing, so it shouldn't be. Shouldn't be very hard to do. Any questions about this at all?
Don't like the minus a bit on this.
You don't like the minus a bit on S2. Which S2? S2 column, first row.
Yes.
You don't? Why not? So where does that come from? Well, I don't know.
Nothing changes from a minus a half.
Doesn't fit. There's minus 1/2, is there? And then you do what? You don't do anything? You sure? So maybe that should be minus 1/2 then, I guess. That's been wrong for 2 years and nobody has told me. No, you're probably right. Okay, what else do you not like? Would be the error finder in residence. Okay. Any more questions? Anybody else? No? Good. So who's actually done anything at home on this? At all? Anybody else? Well, that's is this week, extraordinarily, there is a prize. So still no one has done anything on this at home? Oh well. That's a shame. Hmm. Can you please take one? I'm sure I can't keep it for next week. I'll have to give it to Killian instead, the prize. Anyway, there is a changing the objective function kind of section on Moodle, but I haven't printed it yet, but you can find it there. And unfortunately, what it does is it solves the homework exercise for this week. So I can't give any prizes next week because it's already solved in the book, and we're going to go through it this time. But what? That's fine. Okay, the exercise is we're starting with something like that. An LP problem, which I've sent out. Have you got it, everyone? Good. And yeah, this is the final tableau, so there's no surprise there. Now, okay, when we're so what happens when we change the? I'm going to cover it again so I know you. So this is the tableau. So if we change the objective function somewhere, somehow, what's going to change in this tableau when you look at it? The objective row. Some things in the objective row are going to change. Nothing is going to change in the top part because there's nothing that's got anything to do with the objective in the top part. So it's only the objective row. Okay, that's the observation we're making one. Now, what is this C-B? The objective coefficients of the basic variables. Is it? Yes. What's this C? The objective coefficients of all the decision variables. Okay. So it seems like the situation is going to be different depending on whether what we're changing is the coefficient. Let's say we're only changing one, whether it's the coefficient of a basic variable or a non-basic variable. Which is going to be easier? Non-basic. Why? Because it doesn't appear there. It only appears here. And so if you're only changing one of them, you're only changing one of the boxes. Okay. That's the observation. So I'll write this. So I'll write this. Shall I write this? No, I'll probably write this. I'll write this here. Okay, changing the coefficient of a coefficient of a decision variable in the objective. There are two cases. One, non-basic variable. That's easier, slightly. And that says that, so only one entry in the Tableau changes. Just talk through that. Okay, so that only influences, because that's only one entry in this C vector, so only one entry. This bit of the Tableau is going to change. Good.
Still right, you know.
I'm still moving it. What are you writing? Are you writing something about this?
Writing down what is there.
Yeah, I've left it there. Look. Are you still writing that? The two cases.
Sorry.
Yeah, okay, right. There are two cases. You ready?
Yeah, I don't.
Or are you still writing?
No, I don't know.
No. I know. I'm messing about, but I shouldn't be. And then the student survey is going to come and will be comments. The admin is very nasty and messes about students who want to take notes. And not enough time is left for us to take notes. I don't know what else. Like, it's going to be a disaster as every year. Now I have to write 3 pages of actions to take, so that I will let students finish taking notes. I won't mess about. Now make sure that there are enough videos on Moodle that will help you pass the exam. Does anybody still take writing it? Have I spent enough time talking rubbish? Okay, so right. So now the coefficient changes from 3 to 8. I'll probably go away with this and uncover the original formulation. So no, it just won't fit. Is that still readable, or is it too small now? Yeah, but you're in the front row. No. Yeah, so x1, that thing changes from 3 to 8. So how is, I can't read myself. So that's the only entry. Right? We're changing x1. So x1 column is the only place where something's going to change. This looks like a 4. Yes, it's a 4. And so what's it going to change to? is going to change to 7. No. It's going to change to 9. No, it's going to change to 8. Okay, so back to this. It's in that R. Okay? This whole huge thing doesn't change. Whatever it is, it doesn't change, so you can ignore it. So there was something, there was minus, what was the C? 3. Okay, so there was minus 3 plus something. That doesn't change. And you got 4. Okay, so this 4 is minus 3 plus something.
So,
Now you're going to have minus 8 plus that same something. So C1 went up by 5. This has to go down by 5 because it's the negative. Okay, so it's going to change to minus 1. Does everybody agree? And everything else stays the same. Right, so what's next? Is that it? Pardon? Got minus 1 in the objective. Ah, the objective row. Okay. Is that a good thing? Is that a bad thing? So all we need to do? Pardon? Yeah, it won't be optimal. And if you want the new optimal solution, what do you want? What do you need to do? It's just a good old pivot step. Okay, so this is now minus 1. Where do you pivot? Suppose here, because there the ratio is 10, and there the ratio is more than 10, and this is negative, so you don't want to use that. So where the circle is around the 2, that's your pivot element. Okay? So this is actually left as homework. And because I haven't given you a next table, an empty one, that sort of suggests that one pivot step should be in. Okay, that was quite easy. Now, case 2 is changing the basic variable. An ISS comment. Jan puts papers on the visualizer in a completely random fashion, impossible to follow. Now, you see, the advantage of me telling these comments to you is I've kind of diffused it, right? So you want to complain about all these things, and I've already mocked them, so you can't complain about them. It's great. Just invented this method of avoiding that. This is a bit harder, but still only the object row changes. And then, in both cases, if Tableau no longer optimal, need to pivot. Okay, that's what we saw in case 1 already. But in the basic variable, case it's a bit harder because in general anything in the objective row can change because the CP dash can change. So what does the example say? The example says that C3, the objective coefficient of x3, changes from 5 to 3. And now there are two ways to do it. One is you do it in 1 step, and the other one is you do it in 2 steps. Which method do you want? 1 step? Okay, 1 step. So, yeah, 1 step. 1 step. 1 step. Easy. 1 step. Do we have a spare handout? Okay. It's like this. I can show you the previous Tableau at the same time. Now I've covered it, so I rely on your memory to remember how you get the objective row when you know the rest of the Tableau. Okay? This was the first thing we were doing today when we were solving the exercise from last week. We firstly constructed the whole top part of the Tableau, and then from that we were doing the objective. Remember? Okay, so the way it went was we said, so what's the coefficient of x2? 2 in the objective, so it's 2 times this. What's the coefficient of x3? 5. Okay, so it was 5 times this. And s3 is, okay, so that's 0 times this. And then for the x1, so for val and the slack variables, that was it. For the x1, x2, and x3, we had to subtract the values. So this was actually, we had to take away 3 from what we got, and we had to take away 2 from what we got, and we had to take away 5 from what we got. Okay? So now what am I changing? I'm changing this 5 there to 3. So what's going to change? This 5 is going to change to minus 3. This is minus 5 to minus 3. And this 5 is going to change to 3. Okay. So if you ignore this home, what's going to happen is the new objective is going to be, we won't be adding 5 times this row, but only 3 times this row. So it has to decrease by 2 times this row. Yeah. With the only exception of this entry, which will, this is also going to change. These two are not going to change, so this is also going to change. But then we kind of know what to expect with this, because that's a basic variable. So without thinking any further, this is still going to be a 0. It has to be a 0 because that's a base example. Okay, so that column is easy. And in the rest of it, compared to the original values in this tableau, it's going to decrease by 2 times the x3 row. Okay? So what I have here is, I had 3, 13, 50, and I'm taking away 2 times 230. So what do I get? What do I get indeed? 890, yes, that's the same. Okay, and here I had 4. I'm taking away 2 times 3/2, is that right? So I get 1. Yeah, agreed? And there I had 0, but well, I'm taking away 5 times 0, so no surprise there. 2 times 0, sorry, I'm taking away. Here I had 1, I'm taking away 2 times 0, so I still keep the 1. Here I have 2, I'm taking away 2 times 1/2, so I only have 1. And this is basic, so it's have to stay 0. And the rest remains as it was. Okay, so this remains 1. And thing stays as it ever was. No, what's happened? Wrong way. Okay, I've not done any magic. I just copied all the numbers. Are they correct? Okay, so this is what you do. Why does it say restore simplex property? Well, it has simplex property, so why does it say restore simplex property? Okay, I'll ask again because people will copy it. Why does it say restore the simplex property if this tableau already has the simplex property? Pardon?
No.
It does that because it was ready for the method where you do it in 2 steps. But you asked for the one that does it in 1 step, so you don't need to do restore simplex property. So no need to restore simplex property. Okay, that was only that's only needed if you do it in 2 steps, and you don't know how to do it in 2 steps now, so I won't tell you because you'd only get more confused than you already are, and you're already confused enough. Okay, any questions about this? No. So what do we do next? Nothing, because it remained optimal. Aha. But if something in the objective row changed to negative, we'd have to pivot. Well, what this it didn't. It just the value went down because we decreased the objective coefficient. Okay. Now there's also question C, and C is a taster of what we'll be doing next week, namely when you start wiggling with the coefficient of x2, start increasing it a bit or decreasing it a bit. For some values of the C2, like we changed the coefficient of x3 with C3 to post-optimality 3, and we didn't have to pivot. The basis that was optimal is still optimal. Okay, the objective has a different value, and so on, but the basis is always the same. Okay, and question C asks you how much you can change the coefficient not to have to pivot. That's what's asked here. And you can think about it, because that's based on that kind of idea, how we got this tableau. We change it by 2, we have to take away 2 times that row from there. We change it by 7, we have to take away or add 7 times the particular row, the objective row. So how much can we keep changing C2 so that we wouldn't get any negative numbers in the objective row? Try to think about it, and that's something to do next week. Though, any questions about today or anything else? No? So that's it then. Thank you.